Good morning, everyone. Let us start the new chapter today. Playing with numbers, chapter number 16. Chapter 16. Playing with numbers. Before playing with numbers, we need to understand the numbers in a better way. Whatever you want to play with, you have to first understand their rules, their forms, everything you need to understand. Then only you can play with that thing properly. So let us see. We have seen normally we use which number system? Please tell anyone. In computer, you have studied many number systems. Which number system do we study normally from class 1? We are studying decimal number system. Very good. Decimal number system. We follow this number system all throughout the world in normal cases. For computer purposes, we go for binary and hexadecimal, but normally we use decimal number system. That is very easy for us to solve the questions based on this number system. Now, the thing is how it helps. First of all, deci means 10. So that means there are 10 numbers that we are using repeatedly, like 0, 1 till 9. This we have done in computer also. Now, if we have a number 3, 2, that is 32, what do we call it? Actually, we have position weights. If we have a number 32, we have some position weights. And we have two things, face value and place value. Class, you must have seen we have two concepts, face value and place value. Please tell me, what is the face value of 2? What is the face value of 2? It is 2 only. Very good. What is the place value of 2? What is the place value of 2? Yes, it is once only, but I am asking what the place value, that will be 2 into 10 power 0. That is 2 into 1 only. Answer is 2. So in this case, the place value and the face value are exactly same. But in the case of 3, what is the face value? Please tell. In the case of 3, what is the place value? It is 3. And what is the face value? What is the face value of 3? It is 30. Why? Because 3 is the digit multiplied with the position weight. The position weight is 10 power 1. So the answer becomes 3 into 10, that is 30. So we can see whatever number we have to give the position weight to it. If we are dealing with decimal number system, we can write like this: 3, 2, 6, 7, 8. I can say the position weight is 10 power 0, 10 power 1, 10 power 2, 10 power 3, 10 power 4. If you remember, sir, why have you written 3 into 10 power 2? But actually it is 1. By mistake it is looking as 2. Okay. Now I think it is fine, Joel. It is 1 only. So class, we have understood the concept of position weight, that the rightmost is 10 power 0 or 1. The rightmost, that you say always once, actually that once is not once. That once is actually 10 power 0. And we know any number power 0 is 1. Yes, we did this in 7th also. And if you remember, Smriddhi, I have told you the same concept for binary number system also. In that case, we had 2 power 0, 2 power 1, 2 power 2, 2 power 3. Similarly, we had for octal number system 8 power 0, 8 power 1, 8 power 2. Yes, if power is 0, it becomes 1. And you must be knowing, when you borrow something, like you have the number, you are doing subtraction, suppose 25 minus 7. Class, Sir, it contains alphabet also. No, alphabet is there only in hexadecimal. A, B, C, D, E, F for 10, 11, 12, 13, 14, 15. We have studied in hexadecimal. Okay, class, if you subtract this in the childhood, they told you to cut this thing, make it 1, and to cut this thing and make it 15. So what they were doing actually? Class, what they were doing actually, because it was decimal number system, they were taking 10 from the padosi and making it 15. Class, are you understanding this thing? The subtraction we have done till now was following a simple rule. Because it was a decimal number system, the borrowing was of 10 only. If the question was of octal number system, in that case, what was borrowed? 8 was borrowed. If you borrow in an octal number system, तो आपका 8 borrow होगा. ठीक है? So you need to understand which number system you are dealing with. Okay? You need to understand which number system you are dealing with. Depends on the base. Very good. So let's start. The concepts first. Class, 1 second. Pause recording. Okay. Now, first, we need to give a general thing, a general formula, general number. It would be confusing. What, beta? Ananya, what is confusing? Please tell. If you have a, acha, borrowing 8, yes. Vardhan, every number system has its own uses. Binary, you know already, is used in computers, but sometimes it takes a lot of space. To reduce the space or the number of digits, we went to hexadecimal. Yes, Vardhan? So computers are mainly using that binary and hexadecimal. Others, decimal is being used by us only. Octal, you can search and try to understand where these number systems are normally used. Okay, you can check over there. It is like that only. In some countries, they were following octal system. In some countries, they were following hexadecimal, like that. As we are using centimeter, suppose. Some are using meters. So that is why we made a SI unit, so that all over the world we are using a similar sort of unit. Okay, in cities, if you purchase a property, the area is written in meter square. Sir, in hexadecimal characters are there, yes. How to convert it to decimal, but there are some ways for that. If you want, you can search on Google also. They are very easy. Okay, for your extra knowledge you can do. Octal is used in computer only. Okay, octal is also used in computer, just as saying. Now see the general way. Suppose you have a 2-digit number. Please tell me, class. AB. If this is a 2-digit number AB, tell me how will you write it in the expanded form? How will you write it in the expanded form? You know that position weight of this is 10 power 0. Position weight of this is 10 power 1. We can write this as 10 into A plus B. Class, is this correct? Is this correct? Okay. So class, tell me, if I say 2-digit number AB is equal to 2-digit number BA, is this thing correct? Please tell me. After understanding this thing, can you say this is correct? This is not correct. Okay, tell me, this can be correct only in one case. Please tell me the case in which it could be correct. Only if, no. Tell me fast. What should be the nature of, very good Vardhan. Others please try. what should be the nature of A and B so that these two become equal, AB and BA? Please tell. Please tell, please tell. Vardhan got the answer. Others, please try. Others, please try. In what condition A and B ऐसे क्या इनमें रिलेशन होने चाहिए so that this relation becomes equal? See, if they both become equal, if they both are same, we can see if you take 1 1 or you take 1 1, they are same things. If you take 2 2 or you write 2 2, that means even if you change the position, nothing is changed. So only possible A is equal to B. Only if A and B are equal, then only you can say AB is same as BA. Class, are you able to understand this thing? ऐसा क्यों हुआ? Are you able to understand? I said this thing. Okay, okay. Just okay, beta. Thank you. Also in multiplication. Acha, that way you are saying. Okay. Ananya is saying, sir, we have studied in multiplication of integers about the property known as commutativity. Yes, that is a confusion. Commutativity is a confusion here because, okay. Let us see. Class C, we have studied A into B is same as B into A because it is commutative property. But in this case, it is different because here we are discussing the value. The value. In this case, it will not work because when you see the value, it is actually 10A plus B, and BA means 10B plus A. That is why here it will not work. Okay, that is correct. AB is equal to BA by commutativity property. But in decimal number system, if AB is a number and BA is a number, you can't say they are equal. Okay. Yes, Ananya, but try to understand. Here AB is used for a number whose value is actually 10 into A plus B, and BA is a number whose value is 10B plus A. That is why their values are getting different. Okay. For example, if I take 2 into 3 or I take 3 into 2, I will get the same answer, no issue. But if the numbers are 23 and 32, can you say they are same? Ananya, please tell me. These are two conditions. You are talking about this condition. I am agreeing it is correct. But can you say this is also correct? Are they equal? No, they are not equal. 2 into 3 is equal to 3 into 2. That is correct. But 23 and 32 are not equal because 23 is actually 20 plus 3 and 32 is actually 30 plus 2. That is the difference. Okay. Although digits are same, but values are changing. Okay. So I think this concept is clear to you now that why, yes, only in the case when the numbers are same, only in the case when the numbers are same, like 22, 33, 44, 55, even if you reverse the digits, nothing will change. Okay. Now tell me one more thing. What is a general form of 3-digit number? If you have a 3-digit number ABC, what will be its general form? Please tell. Please tell the general form of ABC. It is a 3-digit number. What is? Very good. Hiteshri, it is 100 or 10 power 2 into A plus 10 power 1 into B plus 10 power 0 into C. This is the general form. Just okay, you are writing the powers. Fine. Correct. So all are correct. Very good, Joel. But Joel, you wrote everything in multiplication. You need to use plus. Yes, yes, Joel. That is fine now. So let us see the next thing. What is actually playing with numbers? You all have seen people telling you to think of a number in your mind, do this thing, do that thing, and do this thing, and finally they will say the number you thought is this. Have you seen this kind of games? Actually, these games are made on these structures. These kind of games are made on these general formulas. ये जनरल फॉर्मूला हमें हेल्प करते हैं टू मेक दीज गेम्स. आई विल टेल यू हाउ. ओके, आई विल गिव यू वन एग्जांपल. Similar thing done by the magicians also. They also doing some tricks. They are good at doing हाथ की सफाई. But sir, which games? Okay, I am playing the game with you. Think of a number in your mind. Everyone, think of a number in your mind and tell when you are done. Done? Okay. Now, okay, 1 second. Do one thing. It should be a two-digit number. Okay. Choose a two-digit number in your mind. Okay, done. Now, reverse the digits. After choosing the two-digit number, whatever you have chosen, reverse the digits. Done? Done. Now, add this number to the number you are starting with. Add these two. Add, let me call it A, sorry, 1 and 2. So add 1 and 2. Done. Addition done. Now fourth step, divide by 11. Divide by 11. The remainder you will get will be 0. Remainder will be 0. Joel is saying no, sir. Joel, again recheck. Joel is saying his remainder is coming as 2. I took 11. Okay. Okay. Let us see what will happen. So first let us see in general way. Suppose Joel is saying he took 11, na? No, sir, it is not 0. अच्छा ऐसा तो आप लोगों ने गेम को गलत कर दिया. Let us see. Dev Datta is saying remainder is 3. Okay, let us see 11 with Joel example. Suppose Joel took 11. What he did? He took reverse of it. Reverse is also 11, class. Do you agree? Do you agree? If the number is 11, reverse is also 11. And when you add these two, what will happen? 11 plus 11, you will get 22. Now tell me, Mr. Joel, if you divide 22 by 11, what will be the remainder, beta? ये जो 2 आपको मिला है, it is not remainder. Joel, this 2 is not remainder. This 2 is something else. What do we call it? You are getting confused. It is quotient. It is not remainder. Okay, like this you used to divide, na? You can do like that. This also. This is the remainder. Okay. Now who else was saying? Gursharan, which number you took, beta? You take any two-digit number. हाँ बेटा देव बताओ. What example you have taken? Dev, tell me. You took 13. Okay. भाई देव took 13. 13 का रिवर्स क्या होगा बच्चे? What is reverse of 13? 31. Add 31 and 13. What will you get? 44. And when you divide 44 by 11, you will get 4 as the quotient. Remainder is 0. Now let us understand the structure behind it. How it became a puzzle, how it became a game. Because there was a structure behind it. There was a machinery behind it. We need to understand how it is working. Let us see. Suppose you assumed a general number AB. Suppose you assumed a general number AB. Class, fine. AB can be anything. It can be 13, it can be 17, it can be 21, 99, whatever you want. Are you fine with it? Because variable can take any value. Okay, so actually the value of AB is how much? Please tell me, class. The value of AB is, please tell the value of AB, how we expand it, expanded form. Please tell. It is 10A plus B. Now we have done the reversal. It's okay, it's okay, Nanya. Now the reversal, reverse the number. It become how much? It becomes 10B plus A. Any problem, class? Any problem in this thing? I'm just trying to show you how these games are made. You also can make a game on your own. Okay, this way. Now, if I add these two, if I add equation 1 and equation 2, what will I get? I will get 10A plus B plus 10B plus A. I got actually 11A plus 11B, and I found 11 is common. So I can say this, whatever I will get, 11 will be a common thing. So this number is a multiple of 11. I can say when I'm adding these two numbers, this number is for sure a multiple of 11. That is why I was confirm, whatever you will assume in your mind, when you divide by 11, you will get the remainder equal to 0. Class, is it clear? Please tell me. Is it clear how the game is made? Now, suppose I want to change the game. In the same thing, if I do subtraction, please tell me. In the same thing, if I do subtraction of equation 1 and equation 2, tell me what will it become? If I subtract, I will get 10A plus B minus 10B plus A, and I will get 10A plus B minus 10B minus A. That will be how much? That will be 9A minus 9B. 9 is common. Now you can say the game is changed. I will say same thing. Think a number, reverse it, subtract them, and the number you are getting divide by 9. What will be the remainder? Class? Yes, Vardhan, you are correct. What will be the remainder? Again 0. So this way the games are made in mathematics. If you want to make a game on numbers, first make it on variable, because variable are the general thing. If your technique is working on the general thing, it will work on all the numbers, no problem. But the reverse is not true. If your game is working on a particular number, it is not important that it will work on variables. So best thing is always work on variable, and then try to find out a thing from that. That thing can be applied to any number. How to make game from this? You can take a 3-digit number, you can make different combinations, you can divide them, you can multiply them, and try to understand what is coming out. From that you can think of how will you puzzle the people, like that. Okay, in this way only, suppose someone did this for the first time, he found that 11 is common. So what came to his mind? That he said, whatever you will do, that number will be a multiple of 11. A sort of understanding of the concepts. Okay, now the next thing we have to understand is, okay, we have understood the numbers and their reversal also. Finding the variables in addition. Let us see some examples. I hope you will try the questions today. So does it mean in the previous game A was our first number and B was our reversal number? No. AB is our first number and BA is our second number. Vardhan, don't get confused, beta. AB was our first number Suppose you have taken 17. So you are saying A is 1, B is 7. So BA becomes 71, like this. Sir, why you divide 44 by 11 in this case? Because beta, हमारी puzzle ही यही थी. I told you in the puzzle, first think of a number, reverse the digits, add them. After adding the numbers, divide by 11 and you will get remainder equal to 0. Okay. Now let us stop it here only, 9:11. We should have some sort of time. Or we can take one example, then we will stop it. One example only. Just tell me, simple example 1. It is very easy. Find Q. These questions are very easy. I hope you all will try on your own today. If this is a question, we can easily find the value of Q. Class, tell me what is the value of Q, and it should be same also. These two should be same. Very simple it is. Please tell what should be the value of Q, because no, Vardhan, you can see Q plus 3 is giving you 1 at the end. You have to understand this thing. Q plus 3 is giving you 1 at the unit place. I don't know what about the tens place, but I'm sure it is giving you unit place 1. So it should be 8 only, because no other combination is working in this case. So if I take Q equal to 8, what will happen? 8 plus 3 become 11, 1 will be carried, 1 plus 1 is 2, 2 plus 8 is 10, so it is working. It is working correctly. It is fine. So let us stop the recording now.